Good afternoon to all of you. Okay, so a very warm welcome to all of you on the platform of EII. Today we are here to start the subject thermodynamics. Good afternoon to all of you. And before starting the subject, I would like to say some guidelines. Guidelines is that this is the last major subject, and this subject you should revise and you should complete in such a way you should not further revise it, and parallelly you should also revise the mass transfer which has been just completed. Clear? Good afternoon to all of you. So let us start, guys, without any delay. And I told you it is a very easy subject, but you people made it difficult. Reason is that because it may be possible कि कोई आपको ऐसा टीचर नहीं मिला होगा जो उसको सही से क्लियर कर पाए. Otherwise it is very easy subject. Okay, now, so why it is very easy subject and why it is very basic subject? It is basic in the sense of it is a basics of all subjects, because you can say before just I will discuss each and everything later on, but before this I would like to say what is meaning of thermodynamics. So guys, as thermodynamics consists of two words, thermo and dynamics. Thermo means actually heat and dynamic means actually power. The basic purpose of studying thermodynamics in the engineering discipline is to know how efficiently we are able to convert the heat into power. Clear? Thermo means heat and dynamic means power. And the basic, you can say the major, you can say also, objective of studying thermodynamics is how efficiently we are able to convert the heat into power. Means heat into work or heat into power. Are you getting a point? Efficiently. Reverse is not. It means work can be easily converted into heat. For example, if we are going to rub our hand, so by rubbing our hand we are going to do work, and this work can easily transform into heat. Means if you are going to carry out the conversion of power into heat or work into heat in a proper controlled manner, then 100% conversion of work into heat is possible. Okay, if you are going to carry out it efficiently. But reverse is not true. It means the 100% conversion of heat into power is not possible even in the ideal condition. And that's the problem was there in start of 18th century, because in the start, or you can say in the start of 19th century, in the end of 18th century and the start of 19th century, where in the industrial revolution come into action. Good afternoon. Industrial revolution has been come into force in the late of 18th century or start of 19th century, and the major problem in that time the engineers face the conversion of heat into work, because if you want to produce electricity, so you should have some work, means through the turbine produces work, and for this we should inject the high pressure steam. So how efficiently we are able to convert the heat into power? And at that era, the efficiency of and any device which convert the heat into power is called a heat engine. Listen, any device which have capability to convert the heat into power is called a heat engine. Getting? So at that time, whatever the heat engine was available, their efficiency was less than 10%. It means the only maximum 10% of the heat absorbed by the heat engine are able to convert into the power. Rest are wasted. Rest are not able to convert. Rest has to be rejected in surrounding. Now then engineers community has decided to work on this, and then they decided to increase the efficiency of that heat engine which is able to convert the heat into power. Means what modification, what changes we can do in order to increase the efficiency of the heat engine. It means how efficiently we are able to convert heat into power. Are you getting this? The sole purpose, only purpose of this subject is to convert the heat into power. Although we will start with basic definition, first law, second law, zeroth law, entropy and all, but at the last you will found what is the need of studying this subject. The need is only the heat engine. How can you improve the efficiency of the heat engine? It means how can you enhance the conversion of heat into power. By obviously the 100% conversion of heat into power is not possible even in the cyclic process. Some amount of heat has to be wasted in surrounding. That is compulsory. But how can you minimize the amount of heat rejected? If anyhow we are able to minimize the amount of heat that is going to be rejected in surrounding, then obviously we can increase the efficiency. Yes or no? Because if let's say we have certain amount of heat has to be entered into the heat engine. Out of that, let's say 50% has been converted into power and rest 50% is going to waste into surrounding. Now efficiency is only 50%. But with proper design, if we are able to convert 90% of the heat absorbed into power, then only 10% is going to reject. The only way to increase the efficiency is reduce the heat that is going to be waste. But again, at the same time, I would like to say here, in the heat engine, we are not able to increase the efficiency to 100%. It means even in the ideal condition, some amount of heat has to be always reject to the surrounding. That is compulsory. And why it is compulsory, that you are able to know in the later on. So what is the purpose of studying this subject? Just to efficient conversion of heat into power. Is this clear? अभी तो कोई दिक्कत तो नहीं है? बोलो. That I told you the basic purpose, sole purpose. At the last, you will only able to find how efficiently we are going to convert it into power. It means we will conclude all the discussion of the initial lectures, and that all concept will apply to the heat engine. All the concept, first law, zeroth law, second law, entropy, all concept will only apply to the heat engine. How efficiently we are going to convert the heat into power. Okay. So that is the sole purpose. But before this, we should have some proper definitions, some proper terms. What is the first law, what is second law, what is entropy, what is system, what is surrounding. All these things we should know, because this nomenclature will help you to know better understanding about the heat engine. Because I told you the main purpose is just to convert the heat into power. How efficient. Now, so what the definition, how can you define the thermodynamic subject? Actually, the thermodynamic subjects is the branch of science and engineering. It means you might have studied this subject also in the physics in your class 12th elementary class. Yes or no? That's why, and also in the engineering discipline. That's why it is a branch of science and engineering. And the basic, or you can say the most important feature of this subject is that this subject is not restricted to only chemical engineering, not only to the mechanical engineering, not only for electrical engineering. It means it is applicable throughout the science and engineering, throughout the daily life, throughout the universe. It is universal. Because why it is basic subject? Reason is that because this subject deals with all the fundamental laws that governs the physical processes that is going to happen in the universe. Means any physical process that is going to happen in the universe you can take. For example, we are alive. It is physical process. We are alive. Why we are alive? Because of some reason is there. Because we are alive here, it means our entropy is going to be increases. What entropy is there? Although you are not able to understand here, but what I am saying, this subjects will discuss about all the fundamental laws that governs all the physical processes that is going to happen in the universe. What types of physical process is going to happen? For example, if you are going to place a hot cup of coffee in a room, after some time you will find it will be in thermal equilibrium with surrounding. It means it is a simple physical process, but behind this there is thermodynamics. What thermodynamics is there? Thermodynamics tells you the energy has been transferred always from the high temperature to low temperature. Heat transfer subject is limited only to the energy or temperature. Heat transfer is always from the high to low temperature. But thermodynamics is not limited only for heat transfer. Now I told you in that time basic definition between the heat transfer and thermodynamics. Thermodynamics will tell you how the heat is going to transfer. What is the reason for the heat to be transferred? But how the heat is transferred, that is going to be decided by the heat transfer. But why the heat is transferring, that tells thermodynamics. Similarly, in the electrical engineering, I am talking about current. Current always flows from the high voltage to low voltage. Yes or no? Current always flows from the high voltage to low voltage. Water always falls from the higher elevation to lower elevation. Spontaneously, I am going to talk about all spontaneous process. Means जो खुद से होते हैं, means every spontaneous process which are going to happen, they are going to happen in certain direction. There is certain, it is not at random. Anything in the universe that is going to happen, anything, if you are going to think logically, then anything in the universe that is going to happen, there is some particular rhythm is there, particular direction is there. They are not random, they are not at random. Means there is some concept behind, there is some restrictions are there behind that any process to be happen, which are spontaneous. So any spontaneous process which is going to happen in the universe, any spontaneous process you can take, so these spontaneous processes are not at random, they are taking place in rhythm, in some certain directions. So which tells in which direction it is possible and which direction it is not possible. That tells about by thermodynamics. For example, if you are going to drop any object from higher elevation, then simply it will get dropped without doing any work. It is spontaneous. But reverse is not possible, am I right? It is possible reverse. If you are going to drop any object from some certain elevation, it will immediately drop. But reverse is not possible because they are not spontaneous. So every spontaneous process is going to happen in some certain direction. For example, object is going to fall from the higher elevation to lower elevation. Energy will transfer, heat transfer always from the high temperature to low temperature. Reverse is not possible spontaneously. If you want to transfer it, if you want to transfer reverse, means from low temperature to high temperature, you should do some work. For example, refrigerator. In refrigerator, the energy gets transferred from the low to high temperature. It means the refrigerator does what? It removes the heat from the low temperature and transfer to the surrounding. Surrounding is a high temperature. But for this, you are going to supply power in form of electrical current. Yes or no? तुम power supply कर रहे हो. You are supplying power. It is not spontaneous. खुद से नहीं हो रहा है. Current always flows from the high voltage to low voltage. Reverse is not possible spontaneously. Mass always transfer from the higher concentration to lower concentration. Reverse is not possible. Mixing. Now, you can mix through liquids. That is spontaneous. Na? But you can't unmix it. The two gas are there and two gas can be mixed. But you can't separate. If you want to separate the two gases, you should go for the absorption. Am I right? Suppose ammonia air mixture is there. You have ammonia, you have air. Simply expose into atmosphere. It will immediately mix without doing any work. It is spontaneous. Mixing of the two gases is spontaneous. But can you unmix it? Can you unmix it? Yes, you can unmix. You can separate. But you should do some operations. You should do some work. For example, you should carry out absorption. Yes or no? Now, we have born, then death is certain. But reverse is not possible. आप जिंदा हो तो बूढ़े होगे. Now, your hair will get white. Your skin will get decay with the time. So they are all our natural processes. Yes or no? There must be a law, na? There must be law which can define what is the reason for this process is going to happen in a certain direction. Because in universe, some processes are there which are going to happen in only one direction. But at the same time, there are some processes are there which are going to happen in both direction. For example, heating and cooling. We can heat and we can cool as well. Some process which are going to happen in some certain direction, only one direction. For example, heating. So for example, all examples we have told you, that is only one direction. Reverse is not possible. But at the same time, there are some processes which are going to happen in the both direction. For example, heating and cooling. We can heat the gas and we can cool the gas. But still, there is some restrictions are there. Do you know restriction? If you have heat the gas and if you cool it. For example, if you have a 1 liter of glass of water and if you want to heat it, obviously that is possible by supplying the energy. You have supplied the energy. It means system temperature has been increased from the 25 degrees Celsius to 35 degrees Celsius. Listen carefully. If you have not reversible, it is not reversible. Listen carefully, Ritik Verma, what I'm saying. If you have a glass of water and if you want to heat it, let's say its temperature is 25 degrees Celsius and you want to heat to 35 degrees Celsius. For this purpose, you are going to supply the energy either through gas or through electrical power, anything. You have supplied some, let's say, certain amount of energy you have added from surrounding. But now, and you can cool it. But when you cool it, then whatever amount of energy you have entered, equal amount of energy has to be removed out. Yes or no? And if you want to remove it, can it possible to remove in the same surrounding from where the heat has to be entered? Please tell me. Because if you want to heat the liquid, what I'm saying, if you want to Miss Simran, what I'm saying, if you have a glass of water having temperature 25 degrees Celsius and if you want to heat it, then whatever source you are going to use to heat it, the temperature must be more than 25. Yes or no? That temperature must be more than 25. And let's say in doing so, you have added some certain amount of energy. And if you want to further cool it to initial state, from 35 to 25, then amount of heat has to be rejected. And is it possible to reject the heat to the same surrounding, to the same source from which you have absorbed the heat? No, it is not possible. It means again restriction is there. It means system has been come to initial state, but surroundings suffer change. Yes or no? Surroundings suffer permanent change in doing so. System has come back. System has increased from temperature 25 to 35, and again from 35 to 25. Means system has come to initial state, but surroundings suffer permanent change. Yes or no? Please tell me. System अपने initial state पे आ गया, but surroundings suffer a change. So again a restriction is there, although it is possible in the ball direction. Heating and cooling is possible, but again restriction is there. In doing so, system will come back to initial state, but surroundings suffer permanent change. Okay? So again restriction is there. So what is the role of thermodynamics? Role of thermodynamics is just provide the particular laws to define the any physical process that is going to happen. Otherwise ये तो आवारा होके घूमेंगे, इनके लिए कोई लॉ ही नहीं है. So there is some subject, there is some laws are there, and that law must be, because I told you na कि in universe some process are there which are going to happen in one direction, and at the same time there are some process which are going to happen in the both direction, but either in one direction or in the both direction, but there is some restrictions are there. That restrictions will get imposed. That restrictions will get imposed by the subject called as thermodynamics. So that's why I'm saying this subject is not for a particular branch. This is the fundamental subject, because this subject deals with all the fundamental laws. जो भी fundamental laws, fundamental are very basics. All the fundamental laws that governs all the physical processes, जो physical process को govern करे, which are happening in the universe. All the physical processes that are associated. At the same time, I would like to say that thermodynamics will discuss. It is a branch of science and engineering that describes all the fundamental laws for all the physical process which are going to happen in the universe involving energy and energy interaction. Involving energy and energy interaction or energy transformation. वो उन physical process के लिए laws को define करेगा. Listen, the thermodynamics will establish the fundamental laws for those physical processes which involve energy and energy transformation. Energy and energy transformation. Clear? जो जितने भी example दिए, for example, if you are going to drop any object from the higher elevation to lower elevation, it means it is again associated with energy and energy transformation. Why? Because any object at some higher location, higher elevation have potential energy. If you are going to drop it, then potential energy is going to be converted into kinetic energy when it comes down. So this process also involves the energy and energy transformation. Energy and energy transformation means any object at some higher elevation have some potential energy, and if you are going to drop it, then the potential energy slowly convert into the kinetic energy, and before striking, all the potential energy has been converted into kinetic energy. Yes or no? Similarly, a fan is moving. Why for me? Because electrical energy is going to convert into mechanical energy. The fan is able to move because it involves the energy and energy transformation. The fan is able to move because electrical energy is going to convert into mechanical energy. Okay, so this subject will establish the fundamental laws for all the physical processes that is going to happen in the universe and associated with the energy and energy transformation. Clear? Definition clear हो गया? बताओ. It is branch of science and engineering that deals with all fundamental laws, all fundamental laws that govern physical processes, all physical processes involving energy and energy transformation. The fundamental laws that governs all the physical processes involving energy and energy transformation. तो इन जो भी प्रोसेस, जो भी फिजिकल प्रोसेस होंगे जिसमें एनर्जी और एनर्जी का ट्रांसफॉर्मेशन हो रहा होगा, उसके लिए एक पर्टिकुलर लॉ को एस्टैब्लिश करना, दैट इज द रोल ऑफ थर्मोडायनेमिक्स. क्लियर है? रोल ऑफ थर्मोडायनेमिक्स इज जस्ट टू एस्टैब्लिश द फंडामेंटल लॉज फॉर विच प्रोसेसेस, the physical processes which involve the energy and energy transformation, and also establishes a relationship among physical properties and also establishes a relationship among physical properties which are required to describe process. क्लियर? उस प्रोसेस को डिस्क्राइब करने के लिए जो अगर फिजिकल, अगर कोई रिलेशनशिप अमॉन्ग प्रॉपर्टीज आर देयर, तो इट आल्सो एस्टैब्लिश द प्रॉपर्टीज, रिलेशनशिप बिटवीन द प्रॉपर्टीज. फॉर एग्जांपल पीबी के एनआरटी, प्रेशर वॉल्यूम फॉर आइडियल गैस, हाउ द प्रेशर वॉल्यूम एंड टेम्परेचर आर गोइंग टू बी रिलेट. सिमिलरली डिफरेंट थर्मोडायनामिक रिलेशंस आर देयर, ds equal to du plus pdv, like that ना. So it also establishes the what is the relationship, how the Cp for non-ideal gas and real gas are going to vary with temperature and pressure. So it also establishes the relationship among the physical properties which required to describe the process. Clear? The role of subject is, role of thermodynamics, first role is to establish the relationship among the properties that required to describe the process, and second, the most important role is that to establish the fundamental laws that governs all the physical process which involves energy and energy transformation. Is this clear? That is the definition of thermodynamics. Any problem? अभी तक कोई दिक्कत तो नहीं है किसी को? बोलो भाई. Now approaches to study the thermodynamics. If you want to study thermodynamics, then there are two approaches are there. Heading is approach. TD, in short form TD. There are two approaches are there, macroscopic approach and microscopic approach. There are following two approach. TD. Two approach are there, just like in the fluid kinematics, two approach was there, Eulerian and Lagrangian. Similarly, if you want to study thermodynamics, the two approaches there. One is called as macroscopic and microscopic approach. Macroscopic and microscopic. Approach. This approach is similar to the classical thermodynamics or classical, two types of mechanics you might know, classical and statistical. So it is just like classical approach, and here it is also statistical. Classical and statistical. Macroscopic and microscopic approach. It is similar to the two types of mechanics is there, classical mechanics and quantum mechanics, also called as statistical mechanics. Okay, classical and statistical. So what is basic difference here in two mechanics? I am going to discuss here. First I am going to discuss the macroscopic approach or classical approach. Below, any problem, Simran? In this, by this approach, if you want to view, if you want to analyze the thermodynamics, then you should not go at the molecular level. If any matter is there, if any matter under consideration, if any matter, for that matter, if you want to know the energy and energy interaction, or in short form, if you want to study thermodynamics of that matter, then we should not go at the molecular level. It means you should not bother about any event occurring at molecular level in that matter. उस matter में, matter means either solid or liquid or gas. The matter may be either solid or liquid or gas. So any matter, a small quantity of the matter. So in this approach, a certain quantity of the matter is going to be analyzed at the macroscopic level, not at the molecular level. It means we should not worry about ki in that matter what is going to happen at the molecular level. So without bothering any event occurring at the molecular level, we should analyze that matter called as macroscopic approach. Clear hai? Bolo. So in this approach, a certain quantity of the matter is being considered without bothering about any event occurring at the molecular level. Okay. So in this approach, a certain quantity of the matter is being considered without bothering about any event occurring at the molecular level. मतलब किसी भी सिमरन मैं क्या बोल रहा हूँ, कोई एक मैटर लिया आपने, उस मैटर में उसके मॉलिक्यूलर लेवल पे क्या हो रहा है उससे कोई मतलब नहीं है. यू शुड नॉट बॉदर अबाउट व्हाट इज गोइंग टू हैपन एट द मॉलिक्यूलर लेवल. It means in this approach, the knowledge of molecules, molecular behavior is not important. Ki how the molecule of that matter is going to interact, what is going to happen at the molecular level, what are the properties of molecules, how they are going to interact, what are their velocities. That we should keep it aside. So we should not bother about any event occurring at the molecular level. That material should be analyzed. That is called a microscopic approach, and it means it is also called a gross approach. For example, I would like to give you example of microscopic approach. For example, a pressure. I've told you in the fluid mechanics also, just like pressure. Pressure is actually the rate of change of momentum per unit area. The rate of change of momentum between the molecules acting per unit area, time rate of change of momentum per unit area is called as pressure. But we are not going to calculate the rate of change of momentum. We are simply using the Bourdon tube pressure gauge and we are going to monitor it. So that is actually, we are not going to bother how the molecules are going to exchange their momentum. We are not going to bother about that. What are their rate of change of momentum? We are not going to bother about that. We are simply use the pressure gauge and we are going to measure. It is just like a gross level. So this is measurement of pressure. That is a macroscopic approach. Is this clear? So pressure measure करने के लिए we are not going to enter at the molecular level. Simply we are going to use the pressure gauge. For example, if you are going to flatten your tire, then simply they use the device and they measure what the pressure is. They are not going to monitor what is going to happen and what are the rate of change of momentum. So measurement of the pressure is the microscopic approach, and the pressure is a microscopic property. Similarly, temperature. Temperature is what? Temperature is a measure of kinetic energy of the molecules. Temperature is actually the gross kinetic energy of the molecules. But we are not going to bother what are the kinetic energy of single molecules. In this approach, we should not bother about any event that is going to happen at the molecular level. What is the kinetic energy of one molecule and then take average of that. No. We simply use thermometer and we are going to measure what temperature it is. That's it. That approach is called as macroscopic approach. So in macroscopic approach, we are able to measure the properties. We can sense the properties. For example, temperature. Either we can measure or we can sense. कोई hot है, cool है, we can measure. Yes, temperature is high. By cool, temperature is low. And how much cool, how much heat, we can measure by temperature thermometer. We should not bother about any event occurring at the molecular level. So these are the macroscopic approach. Is this clear? Macroscopic approach. At the same time, at the microscopic approach, we should bother about any event that is going to happening at the molecular level. That is very, very difficult, because this microscopic approach is the approach at the molecular level. In this case, it is very important to have a knowledge about the molecular level or molecular interaction, molecular behavior. You should have a proper knowledge about the molecular behavior at the molecular level. But in this approach, in microscopic approach, there is no need of knowledge of molecular level or molecular behavior. Is this clear? At the same time, microscopic approach is the average. Macroscopic approach is the average of number of microscopic approach. So कई सारे microscopic approach का low average gross result is the microscopic, and it is found that microscopic approach is same as the average of microscopic. Then why you should go for the average of microscopic if it is correct? Is this clear? Then which approach is easy for you? Microscopic approach is easy. So in thermodynamics, always we are going to cover the which approach. We are all further study of thermodynamics is based on which approach? Macroscopic approach. Clear? So please write some points about that. In this approach, first point, in this approach, a certain quantity of matter is considered or is being analyzed without bothering, बिना चिंता किए, about any event occurring at molecular level. Second point, this analysis it does not require knowledge of behavior of individual molecules or it doesn't require knowledge about molecular behavior. Clear? And microscopic approach is the effect or result of what? Many particles or average value of large number of particles. तो ये एवरेज रिजल्ट है कई सारे पार्टिकल्स का मिलके, ग्रुप ऑफ पार्टिकल्स का. थर्ड पॉइंट, हैव रिटन दिस. थर्ड, it is result of or it is effect of action of many particles. It is just like cross action. Or result or effect of action of many particles, or you can say it is average value of result of average value of large number of particles. Fourth point, this approach is followed in classical thermodynamics. Used in classical thermodynamics. This is about microscopic approach. Now example is just measurement of pressure, temperature, and in this approach the measured quantity, the variables can be either measured or can be sensed. Is this clear? Next, in this approach there are microscopic measurable quantities are there. There are macroscopic measurable quantities. Microscopic measurable quantities क्या होते हैं बच्चे? The quantities which can be measured by device or which can be sensed. The microscopic measurable quantities which can be either measured or sensed by human. But in the microscopic approach you are not able to measure or not able to sense it by human. Sixth point, the state in this approach state or matter, state means condition, can be described in terms of microscopic measurable quantities. Microscopic measurable quantities. It means we can define the temperature, pressure, volume that can be measured. Volume we can measure, yes, no? By knowing the dimension we can measure the volume. Otherwise the volume is the volume occupied by individual molecules. We should not bother about how much volume is going to be occupied by individual molecules. Instead of that we can simply measure dimension, and by measuring dimension we can measure the volume. Similarly temperature we can directly measure, pressure we can directly measure. So in this approach the matter state means condition of the matter we can describe in terms of microscopic measurable quantities. And what are the microscopic measurable quantities? The quantities which can be either measured or sensed by human is called as microscopic measurable quantities. Is this clear, guys? Please tell me. And in this approach only few number of variables are required to define the system. Only few number of variables are used to define state of system. Clear है? I think किसी को doubt? Only few numbers of variables are required to define the state of system in this approach. Now next is microscopic approach. Now at microscopic point of view you know very well that every matter is considered to be composed of large number of molecules or atoms. Yes or no? ये तो पहला हो गया अप्रोच का. जो in this approach if you are going to analyze the thermodynamics by this approach, then every matter we should consider as a group of large number of molecules or atoms. And in order to analyze any matter in this approach, we should bother about any event that is going to occurring at the molecule level. Third, it requires large number of variables to define the state of a system. And fourth, this approach requires the knowledge of behavior of individual particles, and you should have a proper knowledge of molecular behavior. Yes or no? And this approach is the effect of a result of individual molecules, while microscopic approach was the effect of or result of group of large number of molecules, while microscopic approach is the result of effect of individual molecules. Clear? And this approach is going to be used in the statistical thermodynamics. Difference clear हो गया? बताओ. बहुत easy है नहीं? बताओ. तो from microscopic point of view, microscopic point of view, every matter composed of large number of molecules and atoms. In this approach, event occurring at molecular level has to be bother. Okay, it is effect of action of individual molecules, and that was group of large molecules, but it is action of individual molecules. Clear? Large number of variables are required to define state of a system or matter. Clear? Why large number of? Because molecules are random in the nature. So large number of molecules must be required to define the system state. It require proper knowledge of molecule behavior. Okay, and this approach is followed in statistical thermodynamics. I think it is clear. क्या चल नहीं रहा है क्या? वीडियो स्टक हो गया है. नाउ टेल मी. आवाज़ सही है? कोई दिक्कत तो नहीं है अभी तक थर्मोडायनेमिक्स में? चलो, ये तो अप्रोच हो गया. तो विच अप्रोच वी शुड फॉलो? प्लीज टेल मी. विच अप्रोच इज इजियर टू एनालाइज? ऑब्वियसली माइक्रोस्कोपिक अप्रोच. इट मीन्स क्लासिकल थर्मोडायनेमिक्स. तो अभी हम जो पढ़ने जा रहे हैं वो कौन सा थर्मोडायनेमिक्स? क्लासिकल थर्मोडायनेमिक्स. ओके, इट मीन्स we are not going to bother about any event occurring at the molecular level. If you are going to consider any matter, any system, in that system we should not bother about any event that is going to occurring at the molecular level. We should only bother about at the gross analysis we will do. It means we should go for the approach which are results of group of large number of molecules, which are effect of large number of molecules. Okay, now types of system surrounding and boundary. Heading is ये तो सबको ही पढ़ा होगा ना. तो बेसिक्स पढ़ने में मज़ा आया, थोड़ा सा कहानी कुछ क्लियर हुआ. थर्मोडायनेमिक्स क्यों पढ़ रहे हैं हम? जो सोल पर्पज़ है वो केवल हीट इंजन पे, कि हाउ कैन यू इन्हेंस द एफिशिएंसी ऑफ द हीट इंजन, है ना. सिस्टम, और इन शॉर्ट फॉर्म यू कैन से दिस सब्जेक्ट्स सिंपली एस्टैब्लिश द फंडामेंटल लॉज फॉर द प्रोसेस विच इन्वॉल्व्स द एनर्जी एंड एनर्जी ट्रांसफॉर्मेशन. जो भी प्रोसेस जो एनर्जी और एनर्जी ट्रांसफॉर्मेशन को इन्वॉल्व करता है उसके लिए एक फंडामेंटल लॉज को बनाना, यही रोल है थर्मोडायनेमिक्स सब्जेक्ट का. ठीक है, तो सिस्टम सराउंडिंग एंड बाउंड्री. तो फर्स्ट इज सिस्टम. व्हाट इज सिस्टम? अ रीजन इन ए स्पेस ऑन विच वी आर गोइंग टू focus a study. It is called system. A small region in space on which our study is focused. स्पेलिंग सही कर लेना. सिस्टम मीन्स स्पेस में एक स्मॉल रीजन. दिस इज द रीजन. लेट्स से ओनली वी आर गोइंग टू फोकस आवर अटेंशन. वी आर गोइंग टू फोकस आवर अटेंशन ऑन दैट एरिया, इन दैट रीजन ओनली, इन होल स्पेस. तो दैट इज कॉल्ड सिस्टम. बोलो. System is a small region in space over which we are going to focus our attention. Let's say this is the whole is there. So over this the region, only that region is going to be focused. That is called a system. And anything beyond the system is called a surrounding. Is called as surrounding. तो ये क्या हो गया बच्चे, सराउंडिंग। एंड सिस्टम प्लस सराउंडिंग एज अ होल विल मेक यू यूनिवर्स। called as universe. Okay, yes, quantum at the molecular level. Okay, तो statical plus system plus surrounding as a whole is called as universe. तो system, anything beyond the system is called as surrounding. Clear है? And the line which separates the system from surrounding is called as boundary. Right, please. The line which separates the system from surrounding is called as boundary. The line which separates the system from surrounding is called as boundary. अब ऐसा नहीं ऐसे बनाना, कैसे बना लो, आपकी मर्जी है। ये नहीं लगो यही बनाने, सर्कल बना लो, स्क्वायर बना लो, रेक्टेंगल बना लो, जो आपको अच्छा लगे। The line which separates the system from surrounding is called as boundary. Okay, clear, Simran? The line which separates the system from surrounding is called as boundary. The line which separates the system from surrounding is called as boundary. Boundary एक रस्सी है, धागा है, जिसके इंगे उंगे, मिनट वाले कौन है, मिनट वाले हैं इधर, इंगे उंगे, मेरठ इधर वेस्ट यूपी वाले, इंगे उंगे, इंगे आए धागे के सिस्टम, उंगे गए तो सराउंडिंग। ईस्ट यूपी में हेन्ने उन्ने, और हिंदी में इधर उधर। हेनैया वाला सिस्टम है, हेरिया वाला सराउंडिंग है ना। ओके, इधर उधर। नाउ टाइप्स ऑफ सिस्टम, types of system. System, how many types of systems are there, that I am going to discuss here. Basically there are three types of system is there. One is called as closed system, open system, and isolated system. Closed system, open system, isolated system. What is closed system? Also called as control mass system. Also called as control mass system. Open system is also called as flow system or control volume system. Control volume system. Okay. Now, in closed system, what happen? If any system is there, let's say this is the system. In this system, this is boundary, and anything beyond the boundary is called surrounding. So, ये हो गया system. And control in the control mass system, mass as well as identity is fixed. In this system, mass and identity both are fixed. मतलब there is no mass input and mass output. It means mass flow across the boundary is not allowed. Mass flow across the boundary is not allowed, but energy interaction is allowed. Clear? Energy interaction is allowed. क्लोज सिस्टम, मास को इन और आउट नहीं होगा, समझ गया? बघेल साहब सही बोले, यही पार वही पार। तो मास एंड आइडेंटिटी बोथ आर फिक्स्ड. इट मीन्स मास विल नॉट फ्लो अक्रॉस द बाउंड्री, but energy interaction is there. Means there is energy interaction is there between system and surrounding. P dot can be in or out, but no mass interaction is there. That is closed system. Clear? I think there is no problem. And for example, piston cylinder assembly. In the piston cylinder assembly, that is example of closed system, because energy can be heat. We can heat, we can cool, but we can't add mass, we can't remove the mass. Means mass interaction is not allowed. Pressure cooker. Although pressure cooker में क्या होगा, प्रेशर कुकर में नहीं बोलता हूँ क्लोज सिस्टम, क्योंकि वहाँ पे जो लिक्विड होता है वो वेपर के फॉर्म में बाहर निकल जाता है, तो इट इज ओपन सिस्टम से. हाँ, क्लोज प्रेशर कुकर इज गोइंग टू एक्टिंग एज अ क्लोज सिस्टम एज लॉन्ग एज no vessel is going to move. Otherwise, if vessel is going to be move up, then what happen? The liquid content is going to be transferred in form of vapor. So that become open system. Mass, first point is that mass and identity both are fixed. Mass fixed means that is not going to be clear. Why? Because mass fixed का मतलब क्या है? Suppose 2 kg mass, यहाँ पे टैंक है, इसमें 2 kg liquid है, तुमने क्या किया, 1 kg निकाल दिया, 1 kg ऐड कर दिया. So here it is not a closed system. Why? Because in doing so, although mass is fixed here, but identity has been changed. Clear? That's why I have told you कि mass as well as identity both must be fixed. It means you are not supposed to cross the mass from the boundary. Clear? Third point is that energy interaction is allowed. Now what is meaning of mass and identity? Mass and identity means mass is fixed. तो mass तो यहाँ fixed है कि 2 kg mass है, 1 kg निकाल लिया, 1 kg ऐड कर दिया. But in doing so, what happened? Identity has been changed. That's why if you want to fix the identity as well as mass, the only way is you should restrict, you should not cross the mass across the boundary. Clear? The third point is energy transfer is allowed. Sanika, clear? Energy interaction is allowed. Energy in and out हो सकता है. Example of closed system is closed bottle. If you have bottle and that is closed, tap is tightly closed, then obviously the cold drink, if it is a cold bottle is there, then after placing in the in the surrounding, what happen? It will cool down. Energy transfer is there from the high to low temperature as it is, but no mass is going to transfer. But once it is become open, what happen? The liquid can be vaporized if the air is unsaturated. There is a mass transfer is there. That is not open system. So this bottle is acting as a closed system as long as it is tightly closed. Energy interaction is there but no mass interaction. Am I right, Mr. Karthik? Piston cylinder assembly. Piston cylinder is there. If there is no leakage is there, then it is acting as a closed system, because energy can be interact, energy can be in, energy can be out, but no mass can in, no mass can be out. That is called a closed system. Clear? Now come to the open system. In open system, what happen? Mass as well as energy both can cross the boundary. Mass and energy both can cross the boundary. Means there is no restriction for the mass and energy. Here restriction is for the mass, but no restriction for the energy. Here no restriction is for the mass as well as energy. Mass and energy both can cross the boundary. Okay. If adiabatic system is there, then only mass can be enter and out. Yes or no? There is no. You should not say कि mass and energy both should be entered. No, it can enter. There is a process like that. If adiabatic is there, no energy interaction is there, but mass interaction is there. It's open system. Clear? Now the boundary of control, I've told you in the fluid mechanics, the boundary of control volume system is called as control surface. Boundary of control volume or open system is called as it is same as system and control volume approach. In the fluid mechanics, we told you the control closed system as a system, simple, and open system I told you as a control volume. I told you it is very difficult to track in the flowing system. It is very difficult to track the control mass system. That's why it is better to go a small region in space. Control volume. The boundary of control volume is called control surface. मिट जा भाई, नहीं मिटेगा जा. Boundary of control volume is called control surface, and control surface may be imaginary or can be fixed, or real and imaginary. Next point in this, next point in the I am writing in the same flow system. The control surface may be either real or imaginary. Real or imaginary. Control surface का the boundary of control volume. For example, you can write, for example, nozzle. Nozzle is the very example of, this is nozzle. You know very well, in nozzle input and output is there. This is the, now that is not a fixed boundary, na? That is not rigid. So this is not real boundary, real control surface. This is real. This is a real control surface is there, and this is whole is control volume. You know very well. This is control volume. A small region in the flow space is called as control volume. Through control volume, mass in and mass out is there, and the boundary of control volume is control surface. This is control surface CS1. This is CS2. This is CS3, and this is CS4. Control surface 4. Now, out of 4 control surface, the 2 are imaginary and 2 are real. So CS1 and CS2 are imaginary control surface. Imaginary. And rest 2 are real control surface. Clear है? बोलो. Example of open system is, please tell me, turbine, compressor, nozzle, diffuser, centrifugal pump, जहाँ भी pipe flow, all are the open system. Yes or no? Please tell me. Heat exchanger, open system. Energy भी, mass भी. Nozzle, mass, energy. Although energy is not there, if adiabatic is there, otherwise nozzle, diffuser, turbine, compressor, pump, heat exchanger, flow through pipes, all are example of open system. Clear? In column, isolated system, the system which does not allow either mass or energy is called as isolated system. Does not allow either mass or energy. Does not allow either mass or energy across the boundary. Umar, clear है? Means neither mass nor energy. It's completely dead. Mass भी नहीं हो रहा है, energy भी नहीं हो रहा है, complete dead state. It's called isolated system. It means there's no interaction of the system with surrounding in any way. This is going to interact with system in terms of energy interaction. This open system interact with surrounding in the way of both mass and energy interaction. In this case, neither mass nor energy. It means it's not going to interact in any way with the surrounding. That system is called as isolated system. Okay. For example, a well insulated thermoflask. A perfectly insulated thermoflask. Example of isolated system is well insulated. Let's say here closely tight packed and perfectly insulation is there. Perfect insulation is there. Even cap is also well insulated. Well insulated. No mass interaction, no energy interaction. Yes or no? अरे MS महेंद्र सिंह धोनी अभी आप यहीं पे हैं. एनर्जी इंटरेक्शन इज अलाउड यार. यार बोल भी तो रहा हूँ भाई मेरे. भेजो नोट्स भेजो उसको. तुम अगर यहीं पे अटके रहोगे तो कैसे सुन पाओगे मैं क्या बोल रहा हूँ. सिमरन समझ रहे हो नहीं? लिखना लिखो भले मत. समझ रहे हो नहीं समझ रहे हो बताओ. कुछ भी तो ऐसा नहीं है जो लिखने वाला हो. लिख लियो, अच्छी बात है, लिखना तो है ही है, बट हाँ समझ के लिखो. अब रुझो थोड़ा से बंद होगा 2 मिनट के लिए. 1 मिनट बोलो भाई. क्लियर? नेक्स्ट राउंड. तो ये तो गया टाइप्स ऑफ सिस्टम, सराउंडिंग एंड बाउंड्री. नाउ thermodynamic state. Heading is thermodynamic equilibrium first. Thermodynamic equilibrium. Equilibrium. Sequence wise चलते चलेंगे. Thermodynamic equilibrium. What is thermodynamic equilibrium? If a system is said to be in thermodynamic equilibrium if equilibrium with its surrounding with its surrounding if it is thermally, chemically and mechanically equilibrium with its surrounding. Means any system is said to be in thermodynamic equilibrium when the system is thermally, chemically as well as mechanically equilibrium. Then we can say yes, it is thermodynamic. So thermal equilibrium means equality of temperature. Thermal equilibrium, it means equality of temperature. Means temperature of system and surrounding is same. If system is in chemical equilibrium, it means equality of chemical potential in broad sense. Equality of chemical potential. Now mechanical equilibrium means there is no imbalance forces. Imbalance forces are absent, or you can say equality of pressure. Pressure, force are equal. Clear? The thermal, chemical and mechanical. But when any system is thermally, chemically and mechanically all three, then you can say it is combinedly called thermodynamic equilibrium. It means when any system is in thermodynamic equilibrium with its surrounding, means there is not possibility of heat transfer, no possibility of mass transfer, and there is no any imbalance forces, so that piston can move up and down. For example, what is meaning of mechanical equilibrium? Suppose if a piston cylinder assembly is there, clear, and let's say here the gas is there, any gas, okay, and that gas will exert some pressure. Let's say exert the pressure of on the wall of the piston of 10 unit. I'm not going to bother about the unit of that. 10 unit is there, and outside the pressure is, let's say, 1 atmosphere, 1 unit. Then obviously here the pressure imbalance is there, force is imbalance on the piston, and since inside pressure is more, then that's why it will push the piston against the 1 atm. Okay, that's why it is imbalance. But when it is out 10 atm, what happened? No imbalance of the forces are there. It means there is no movement at all. So there is mechanical equilibrium means there is no imbalance of the forces. Are you getting, Mr. Karthik? It means pressure are equal. On piston cylinder assembly, I can show you कि mechanical equilibrium means the pressure exerted by the gases on the wall of the piston is 10 unit, and if the outside pressure which are going to exert on the piston is also 10 unit, then there is no imbalance in the pressure. It means the piston will not move at all. But if there is imbalance, then piston will move, and if the piston will move, then what happen? The system will change its state. Yes or no? Please tell me. The system will change its state. Please tell me. State means what? Condition of system. Now here at this condition, pressure is P1, V1 and T1. But when there is imbalance of the pressure forces there, then piston will move. And if piston will move here, and that movement will reach till the new equilibrium will be established. And once the new equilibrium will be established, what happened? The state of the system has been changed from P1, V1, T1 to P2, V2, T2. But when the pressure is not imbalance, no heat transfer. Now at the same time, although the pressure is same here, what I'm saying, although the pressure is same here, but temperature is different. In system and surrounding, temperature is different. What happened? Heat transfer is there. If the heat transfer is there, then gas will get cooled down. And if the gas will cool down, then what happened? From ideal gas law, PV equal to nRT. Try to understand what happened. PV equal to nRT. Now, it is closed system is there. The number of modes will be fixed. Now, if the temperature will cool down, let's say I've told you system and surrounding are at different temperature, although pressure is same. Although the pressure, there is no imbalance of pressure forces, but there is imbalance in temperature. Means system is in mechanical equilibrium but not in thermal equilibrium. then again the state of system will get changed. Yes or no? Then again the state of system will change. Pressure will remain same but volume will get decreased. Yes or no? Pressure remain constant but volume will get decreased. Yes or no? So again the state of system has been changed. It means, and the change of state of system is called as process. It means process is going to happen. If system is going to change its state, it means it is only going to change when the process is going to happen, and the change of state of the system is called as process. Are you getting my point? Now, although what I'm saying, if system is in mechanical equilibrium as well as thermal equilibrium, but there is a chemical potential difference is there. Now it means the species are going to transfer from, a chemical reaction is going to happen. Then again, the state of system will get changed. If the chemical reaction will change, now then conversion means reactant A is there, and after that reactant A has been converted into V. So what I'm saying, either if any one of the three, if at least any one of the three will present, then system will change its state. But if you don't want to change the state of system, what the condition must be? If you don't want to change the system, if you don't want to change the system of its state, what the condition must be? अगर तुम नहीं चाहते हो कि सिस्टम अपना स्टेट चेंज करे, तो इसका मतलब क्या होगा? सिस्टम मस्ट बी in thermodynamic equilibrium. Yes or no? The system must be in thermodynamic equilibrium. It means it must be thermally, chemically as well as mechanically equilibrium. Yeah. It means when the system, even any system, let's say our body, if our body is going to be considered a system, जो मेरा body है उसको मैं system बोल रहा हूँ, and anything beyond the system is called surrounding. And if nothing is going to happen, it means we are in dead state, because here we are going to interact with surrounding in any way. For example, we are going to transfer the mass, we are going to transfer the energy in form of sweat. Yes or no? So our body is going to interact with surrounding in any way, either in heat transfer or mass transfer, or you can say in the unbalancing of the pressure forces are there. If our body is not going to be interact with surrounding in any way, our body is said to be dead state, and every dead state is at the condition of equilibrium. Yes or no? Please tell me. Is this clear, Simran? So what is the condition for the system to not to change its state? It means system must be in thermodynamic equilibrium. And whenever I'm saying कि system is in thermodynamic equilibrium, it means system is not in position to interact with surrounding in any way. System is not in position to interact with surrounding in any way. Okay, so this is called as thermodynamic equilibrium. Now it's clear. Now I've told you a word called state, thermodynamic state. What is state? Condition of system is called state. Now it is very important point to understand what is state. Right now heading is thermodynamic state. Thermodynamic state. Yeah, isolated systems are always in thermodynamic equilibrium. I've told you. Now, what is thermodynamic state? State means what? Condition of system is called state. कि क्या तुम्हारी state क्या है? किस condition में हो तुम? किस state में हो? The condition of system is called as state. Okay. Now, and how can you define any system as state? That I am going to show you. The beauty of this subject. And only the first lecture is important, sir. Today's lecture is very important to understand the basic of thermodynamics. Now, any system, किसी भी system को आप state कब बोलोगे? Any system is called as a state because what is the definition of state? I am going to show you. Thermodynamic state is the condition of a system at which we can define the properties. Listen, what I am saying. How can define the thermodynamic state? The thermodynamic state means it is a condition of a system. Thermodynamic state is a condition of system at any stand. किसी stand पे, at any time, at any stand. Listen carefully. Thermodynamic state is the condition of system at any stand, at which you can define the system by its property, where properties of systems are fixed. I told you the word called as stand. I am going to define the call as stand. At a stand, once again listen. Any thermodynamic state is defined as the condition of the system at a particular instant at which you can define the system. And to define the system, you should know the properties. For suppose I tell you this is a system. This is system, na? And this system can be defined as state. It is an initial state. Now, how can you define the initial state? You can define the initial state by its properties. Which properties? Because we are going to discuss the macroscopic approach, then we should define the system with which properties? Macroscopic measurable properties are pressure, volume, temperature. Means now let's say I'm going to say P1, V1, T1. now we can define the system as a state P1, B1, T1. Yes or no? Please tell me. So to define the pressure P1, the pressure of what? Pressure of the system, na? The pressure must be uniform. Yes or no? Volume actually extensive property. Temperature must be what? Uniform. So I should not say the volume. Why? Because volume is extensive property. Volume cannot be said uniform throughout because volume is extensive property. So what definition is there? Ki we can define any system as a state when we can define the intensive properties of the system. The intensive properties of system must be uniform at that instant and it must be invariant with the time. Are you getting my point? Invariant with time is what? At that instant it should not be vary. Although from one time to the instant it may vary. But any system can be, if you want to define the system, you should know the pressure P1 and temperature T1. Yes. Yes or no? बोलो. तो उसका स्टेट डिफाइन करोगे कि हाँ ये P1 है T1 है. बोलो. तो कंडीशन क्या है सिस्टम की? इसका प्रेशर P1 है T1 है. तो we should define the system states by its intensive property. I will discuss what intensive property. Any system is said to be defined as a state at that instant when we can define the system by its intensive properties. तो properties को define होने के लिए क्या होना चाहिए? System को interact नहीं होना चाहिए ना. अगर interact होगा तो क्या होगा? Change होगा time. So at that instant, at least at that instant at which we can define, we are listen what I'm saying. What is the criteria, Simran? What is the criteria for any system to be said as a state? किसी system को हम किसी state में कब बोलेंगे? क्या criteria होना चाहिए? Criteria is that the intensive properties must be uniform. First, uniform होना चाहिए. Intensive means pressure is not like that कि यहाँ पे कर रहे हैं, यहाँ pressure लगा, यहाँ pressure लगा, यहाँ pressure लगा. It should not like that because we are going to define the system. तो सिस्टम की प्रेशर एवरीवेयर यूनिफॉर्म, टेम्परेचर एवरीवेयर यूनिफॉर्म. तो व्हाट द क्राइटेरिया फॉर एनी सिस्टम टू बी सेट एज स्टेट? द इंटेंसिव प्रॉपर्टीज मस्ट बी यूनिफॉर्म. सेकंड, इट मस्ट बी इनवेरिएंट विद द टाइम. मीन्स टाइम के साथ वेरी नहीं करे. द क्वेश्चन इज दैट अगर टाइम के साथ इफ इट इज नॉट गोइंग टू वेरी विद टाइम then what happened? It means the process is not going to take place. It means system is in thermodynamic equilibrium. Yes or no? If nothing is going to happen with the time, if nothing is going to happen in the system with time, what does it means? If nothing is going to happen with the time, what does it mean? It means the system is in thermodynamic equilibrium. Yes or no? Nothing is going to happen. System is not going to interact with surrounding in any way. And if the system, and that's what I told you, every state is in thermodynamic equilibrium. Every state is in thermodynamic equilibrium. Why? Because, and the question is that, I told you, for any system to be set as a state, the intensive property must be यूनिफॉर्म एंड इट मस्ट बी इनवेरिएंट विद द टाइम. तो इनवेरिएंट का मतलब क्या है? टाइम के साथ उसका प्रेशर, उसका टेम्परेचर वेरी न करे. तो वेरी नहीं करेगा तो प्रोसेस होगा ही नहीं, और प्रोसेस नहीं होगा तो थर्मोडायनेमिक्स पढ़ने का मतलब ही नहीं है. व्हाई? देयर इज नो मीनिंग ऑफ स्टडीइंग थर्मोडायनेमिक्स बिकॉज थर्मोडायनेमिक्स, इफ यू वांट टू स्टडी थर्मोडायनेमिक्स, इट इन्वॉल्व्स एनर्जी इंटरेक्शन. तो इफ एनर्जी इंटरेक्शन इज टेकिंग प्लेस विद सराउंडिंग, व्हाट हैपन? द स्टेट ऑफ सिस्टम इज गोइंग टू चेंज. यस और नो? नाउ वी कैन यूज द वर्ड कि we can define the system as a state at least for that instant the property must be invariant with the time at which we can define, we are going to define the system as state. At least उस टाइम के लिए उसमें चेंज नहीं होना चाहिए जिस टाइम पे हम सिस्टम को बोलने जा रहे हैं स्टेट. फॉर एग्जाम्पल आई टोल्ड यू कि व्हाट इज द क्राइटेरिया फॉर एनी बॉयज, एनी स्टूडेंट टू बी सेड आइडियल स्टूडेंट. तो यू कांट बी आइडियल एट ऑल टाइम, है ना. यू कांट बी आइडियल एट ऑल टाइम बिकॉज भाई स्टूडेंट हो तो बदमाशी करोगे. बट एटलीस्ट जिस टाइम पे हम तुम्हारी बड़ाई करने जा रहे हैं, द टाइम एट विच वी आर गोइंग टू इंट्रोड्यूस यू एज ए गुड स्टूडेंट, यू शुड बिहेव एज ए गुड स्टूडेंट. ऐसा नहीं उस टाइम मास्टर बोल दबे साले. आर यू गेटिंग दिस? एटलीस्ट फॉर दोज इंस्टेंट, एटलीस्ट फॉर दैट इंस्टेंट, दैट टाइम बीइंग एट विच आई एम गोइंग टू इंट्रोड्यूस यू ए गुड स्टूडेंट, यू शुड बिहेव एज ए गुड स्टूडेंट. ओके, तो कम से कम उस टाइम के लिए तो दिखाओ. So it means what the condition is that. That's why I told you. That's why I have used the word called stand. उस stand के लिए. Clear? So any system is said to be in a state. Any system is said to be as a state if its intensive properties are uniform and second invariant with the time, comma. At least at that time, it must be invariant at which we are going to define the system as a state. एटलीस्ट कम से कम उस टाइम पे सिस्टम को स्टेट हम बोलेंगे, जबकि उस टाइम कम से कम उस टाइम पे प्रॉपर्टीज वेरी नहीं करनी चाहिए, उस टाइम बीइंग के लिए नहीं वेरी करनी चाहिए. इज दिस क्लियर? तो लेट्स से व्हाट आई एम सेइंग कि एटलीस्ट फॉर 1 सेकेंड At 1 second, its pressure is P1, V1, T1. At other 1 second, it becomes P2, B2, T2. But at least for 1 second, this system is said to be its property. This system can be defined. Yes, it is pressure P1, its temperature is T1. Can we define yes or no? So for any system to be defined as state, we can define its properties. Which property? Intensive properties we can measure. So and every state, उस स्टैंड पे क्या होगा? उस स्टैंड पे सिस्टम इज नॉट गोइंग टू बी इंटरेक्ट विद सराउंडिंग इन एनी वे. यस नो? तो दैट्स व्हाई every state is always in thermodynamic equilibrium, at least for 1 second or microsecond. No worry, at least for microsecond, at that instant it is going to act as a thermodynamic equilibrium. Yes or no? So every state, because क्योंकि उस स्टैंड पे हम डिफाइन कर रहे हैं, we are going to define yes it is pressure, it is volume, it is temperature. It means at that instant the properties are not going to vary with the time and it is uniform. That's why at that instant the state is in equilibrium. It means every system has a state and that state is always in equilibrium. Yes or no? Sir, intensive property, because intensive property will not depend upon the mass. Volume you are not going to define na. Volume is going to vary from one point to other point. So I am going to say point. Uniform क्या होगा? Uniform, volume is not uniform. Volume cannot be uniform because volume is a gross property. Do you know? Volume is extensive property. And uniformity, uniform means at each and every point you can define the pressure, you can define the temperature, but you can't define the volume at each and every point. Solanki. It is clear, yes or no? So the 2 points that must be noted here. So please write down how can define the thermodynamic state. It is the condition of the system at a particular time, at a particular time or instant. That is very very important. Or instant. तो it is a condition of system at a particular time or instant. ये system की condition है which can be described. How can you describe the condition? By its state variables. Described by parameters of suitable set of values called as state variable. Like temperature, pressure, etc. Okay, clear है? So it is a condition of the system at a particular instant described by a parameters of suitable. तो ये state को define करेंगे किससे? By variables. Which variable? Suitable set of variable. What is suitable set of variable? That I will discuss. Suitable set of variables. Suitable set of values called state variables like temperature, pressure, etc. The question is that how many suitable set of variables should be fixed to define the system. किसी system के किसी state को define करने के लिए to define the state of system, how much the variables must be fixed. कितने variables को fix करना पड़ेगा? That I will discuss on the topic of state postulates. Clear? बोलो. Because I told you, it is clear as no? Please tell me. It is clear state. It is just condition of a system at a particular instant that can be described by a parameter of suitable set of variables called as state variables. And you should underline there state variables. This is one definition. Other way, criteria for any system to be set as state. Criteria for system to be set as state. To be a state. Set as a state. What is criteria? It is subheading of that. What is criteria for any system to be set as state? First, intensive property. Intensive property of system must be first uniform, second uniform and invariant with time comma bracket at least for that instant at which we are defining the system as state. System as state. Clear? And that line I have done here as a particular instant, because from one state to the state will be changed because it is process is there. Okay, so intensive properties of system must be uniform and invariant with time. The two condition is there. And how many variables must be there to define the state? Is this clear? What is state? And every state is in what? Please tell me. Every state is in thermodynamic equilibrium. Clear? Why? Because it is uniform है और invariant है. इसका मतलब कुछ भी नहीं हो रहा है इसके अंदर. At least for those instant at which we are going to define the system as clear है. अरे सर स्टेडी स्टेट अलग हो गया भाई साहब मेरे भैया, इसको बताओ कि इक्विलिब्रियम और स्टेडी स्टेट अलग होता है साहब. स्टेडी स्टेट में क्या होगा बताइए उसको आप. मैं क्या बताऊं, ऐसी क्वेश्चन पूछते हो ना यार. सर स्टेडी स्टेट में हीट ट्रांसफर होता नहीं होता है, बताओ मुझे भैया मेरे. तुम लोग आंसर क्यों नहीं देते हो इस आंसर का? भैया स्टेडी स्टेट में हीट ट्रांसफर होता ही नहीं होता है. मैं क्या बोल रहा हूँ यहाँ पे, स्टेडी स्टेट में यूनिफॉर्म तो नहीं होता है ना सर. यहाँ पे अलग होता है तभी तो हीट ट्रांसफर होता है. हीट ट्रांसफर क्या हो रहा है? ऑल द टेम्परेचर वेरी नहीं कर रहा टाइम के साथ, बट इट इज गोइंग टू वेरी विद द स्पेस ना. मतलब हीट ट्रांसफर पढ़ चुके हो, उसके बाद से ये क्वेश्चन पूछ रहे हो. गर्ग साहब सुनिए सर, इस हीट ट्रांसफर होने के लिए सिस्टम क्या होना चाहिए? तुम लम्ड सिस्टम लो. चलो अब बोलोगे लम्ड है. लम्ड में क्या होगा? यूनिफॉर्म टेम्परेचर है, लेकिन टाइम अभी एट टाइम टी 0 पे क्या है? 100 डिग्री सेल्सियस है. टाइम टी 10 मिनट पे क्या है? 80 हो गया. तो टाइम से वेरी कर रहा है यहाँ पे. ऑल दो यूनिफॉर्म है बट इनवेरिएंट विथ टाइम नहीं है, टाइम से वेरी कर रहा है. यहाँ पे दोनों कंडीशन होना चाहिए, यूनिफॉर्म भी होना चाहिए और इनवेरिएंट भी होना चाहिए. बताइए मुझे एक बार तो, ऐसा कोई प्रश्न बताइए जो स्टेडी स्टेट की बात कर दिया आपने यार. सर दिए क्राइटेरिया को समझिए, यूनिफॉर्म भी है. मतलब कोई भी ऐसा हीट ट्रांसफर का प्रश्न बताओ मुझे एक बार तो, जो स्टेडी स्टेट हो. तुम खुद सोचोगे जो टेम्परेचर उसका यूनिफॉर्म है और उसका टाइम से वेरी भी नहीं कर रहा है. इसमें नॉन यूनिफॉर्म है बट स्टेडी स्टेट है. ये क्या है? ये नॉन यूनिफॉर्म स्टेडी स्टेट. ये क्या है? यूनिफॉर्म बट अन स्टेडी स्टेट. समझ गया नहीं? सर ऐसा मत पूछा करो यार, दुख होता है बहुत अंदर से. तुम तो पूछ देते हो बट दुख हमको होता है. तुमको बस पूछना है, बट हम सब कुछ पढ़ा करके यहाँ तक पहुँचा करके फिर ऐसे क्वेश्चन पूछ रहे हो कि हम अगर बोलते हो स्टेडी स्टेट तो हम क्यों नहीं. बस सर मैंने वहाँ भी हीट ट्रांसफर भी डिफाइन किया था कि स्टेडी स्टेट एंड इक्विलिब्रियम इज डिफरेंट. अब तुम लोग जब ऐसे क्वेश्चन पूछे जाते हैं तो उनको आंसर आप खुद दे दिया करो बच्चे. नाउ क्लियर? तो यूनिफॉर्म एंड इनवेरिएंट इट मीन्स नथिंग इज गोइंग टू हैपन. तो एवरी स्टेट इज ऑलवेज इन थर्मोडायनामिक इक्विलिब्रियम. इट इज क्लियर? बोलो. तो ये तो हो गया हाउ कैन डिफाइन द स्टेट. स्टेट इज द कंडीशन ऑफ सिस्टम. State is a condition of a system at a particular time or instant that can be described by the state variables. तो किसी पर्टिकुलर स्टैंड पे सिस्टम की स्टेट को हम बोलते हैं क्या? जिसको हम डिफाइन कर सकते हैं किससे? स्टेट वेरिएबल से, लाइक टेम्परेचर, प्रेशर. द क्वेश्चन इज दैट हाउ मेनी स्टेट वेरिएबल्स शुड बी फिक्स्ड टू डिफाइन द स्टेट. कितने कितने हैं? बहुत सारे हैं, है कि नहीं? मान लो मैंने बोला कि हियर दिस इज द सिस्टम हियर and this air temperature T1, pressure P1, enthalpy H1. I am going to intensive property, specific enthalpy H1, specific volume, now specific entropy, specific Gibbs energy, Helmholtz energy. Number of intensive properties are there, but how many intensive properties must be fixed to define the state? That is going to be defined by state postulate. Is this clear? Please tell me. Although here it is given ki state variables that can be defined by the state variable, but how many state variables? How many intensive properties? So before this I would like to discuss here what is the thermodynamic variables, है ना? So you can write the point here, every important point, every state is in thermodynamic equilibrium. Every state is in thermodynamic equilibrium. Now what is thermodynamic, what is state variables that we should define. State variables क्या होता है? Heading is state variables or thermodynamic variables. Every term I will clear here. State variable or thermodynamic variable. Write down. State variables or thermodynamic variable. They are easily measured macroscopic measurable quantities. I've told you now. In macroscopic, the system can be defined by macroscopic measurable quantities. They are state variables or thermodynamic variables are easily measured. Easily measured microscopic or microscopic measurable quantities spelling सही करो ना, quantities used to describe the state of system. वही बात आ गई, बोलो। तो स्टेट ऑफ थर्मोडायनेमिक सिस्टम को डिफाइन करने के लिए जो भी क्वांटिटीज यूज होते हैं दैट इज कॉल्ड एज थर्मोडायनेमिक वेरिएबल्स. इट मे बी प्रेशर, टेम्परेचर, एंथैल्पी, एंट्रोपी एटसेट्रा. ओके, नाउ हेडिंग इज स्टेट पोस्टुलेट. State postulate. What is state postulate? It is defining the number of properties to a thermodynamic system in a state of equilibrium. Means it is define how many number of thermodynamic properties must be fixed to define the state of whole system. Clear? It defines number of properties, thermodynamic properties to be specified in order to, just like degree of freedom, fully describe the state of thermodynamic equilibrium. Means state, every state is equilibrium, that is no कि how many number of state postulate will define how many number of thermodynamic properties should be specified in order to fully describe the system. It means अगर कोई सिस्टम है इसमें T है, P है, एंथैल्पी है, तो how many number, it's all must be fixed or only few, that is going to define by state postulate. Clear? बोलो. And that according to state postulate the state of simple compressible system is completely specified by two independent intensive properties. Is completely specified by two independent intensive properties. Clear? बोलो. अगर कोई स्टेट जो है सिंपल है, इन सिंपल कंप्रेसिबल, फॉर सिस्टम सिंपल कंप्रेसिबल सिस्टम ओनली टू इंडिपेंडेंट इंटेंसिव प्रॉपर्टीज मस्ट बी फिक्स, एंड दैट इज व्हाट, टेम्परेचर एंड प्रेशर. तो अगर आपने टेम्परेचर प्रेशर को डिफाइन किया है, या टेम्परेचर वॉल्यूम, विच वॉल्यूम, स्पेसिफिक वॉल्यूम, इंटेंसिव क्या है, स्पेसिफिक वॉल्यूम. क्लियर? प्रेशर यू कैन सो प्रेशर वॉल्यूम, टेम्परेचर वॉल्यूम, मोस्ट इज प्रेशर एंड वॉल्यूम. विच वॉल्यूम? स्पेसिफिक वॉल्यूम, because volume is extensive but specific volume is intensive. It is just like the degree of freedom. So if simple compressible system is there, then only two properties must be fixed. So every term is clear, yes or no? Bolo. What is state variables or thermodynamic variables? The variables which are used to describe the state is called as thermodynamic variables. They are microscopic measured quantities that are used to describe the state of system. Now how many number of variables should be fixed? That is defined by state postulate. And for simple compressible system, only two. And what is simple compressible? I will discuss it. Now, अभी तक कोई दिक्कत है? बोलो. कर सकते हैं साहब, मैं बोलता रहा हूँ उमर साहब. आप वॉल्यूम को कौन सा लोगे? स्पेसिफिक वॉल्यूम बोलता रहा हूँ मैं. यू शुड टेक इट स्पेसिफिक वॉल्यूम. करिए ना, मैं बोलता हूँ प्रेशर वॉल्यूम ले लो आप. भाई आइडियल गैस ला की बात नहीं कर रहा हूँ. जब क्वेश्चन को अभी देखना तो बताना. रस्तोगी साहब, इंडिपेंडेंट हम किस तरह से बोल रहे हैं आप समझ नहीं पा रहे हो. जिसको हम इंडिपेंडेंटली वेरी कर सकते हैं, ठीक है ना. टेम्परेचर को वेरी कर सकते हैं इंडिपेंडेंटली, कीपिंग प्रेशर कॉन्स्टेंट. कर सकते नहीं कर सकते हो दोनों को? समझा करो थोड़ा सा. Now come to the, I have defined thermodynamic properties or thermodynamic variables. How many types of thermodynamic properties are there? Types of thermodynamic properties. Types of thermodynamic properties or variables. 2. Extensive, intensive. Extensive properties, intensive properties. Extensive properties, the properties which depend upon the mass. Property which depends on mass and independent of mass. Call it intensive. For example, let's say this is the system is here. No? This system has pressure P, temperature T, volume is V. Okay, number of mole mass is M. If we are making it half to half, what happens? P become same, T become same. Pressure will not be changed if become half, but volume become V by 2, mass become M by 2. It means the pressure and temperature intensive, while volume and mass are extensive, because on taking it half of the mass, its mass become half here, na? Volume become half. So they are intensive. They are extensive because its value will depend upon mass of system. Mass become half, then its property become half. Now one more you can say here, density, thermal conductivity. क्या होगा बोलो? Rho K. Now rho become half? No, rho become same here. Density तो change नहीं होगा. Now K will be same here. CP will remain same here. So they are also intensive. So example of intensive properties are temperature, pressure, density, thermal conductivity, CP. They are intensive properties. They are intensive. Viscosity, yes, viscosity also intensive. They are intensive. Their property will not change with the mass. Now apart from this, all specific, extensive or intensive. Yes, molecular weight. Apart from this, all specific, extensive are also intensive. Meaning is that, listen, all specific, extensive or intensive. What it means here? Now volume is extensive, but specific volume is, specific volume क्या हुआ? It is inverse of density. For example, specific volume or intensive, specific enthalpy, enthalpy is extensive, but specific enthalpy means joule per kg. If enthalpy is given in joule per kg, they are intensive. Specific entropy or internal energy, specific gives free energy, specific entropy, specific volume लिखा हुआ, specific volume, enthalpy, specific energy, specific energy, specific entropy, yes, specific heat capacity. They all are intensive. Now they are extensive, entropy, enthalpy, because listen, when enthalpy, total enthalpy is extensive, but specific, when it is defined per unit mole or per unit mass, they are intensive. Clear? Suppose I told you enthalpy of a liquid is 20 joule per kilomole. So this is intensive because it is per kilomole. If mass will change, mole will change, then enthalpy will change. Total enthalpy is extensive, but molar enthalpy or specific enthalpy are intensive. Clear? So all specific, extensive or intensive. Already I have written specific heat capacity here. Specific gives free energy, specific Helmholtz energy. All are the, whenever specific I'm talking about, they are intensive. Clear? Yes, latent heat called specific latent heat joule per kg. There are different types of thermodynamic properties, extensive and intensive. So to define the system, to define the state, we should use intensive properties. This intensive property must be uniform and invariant with the time, at least for those time at which you can define the system as state. And how many number of independent intensive property must be fixed, that is called as state postulate. And two independent intensive property must be fixed, and rest we can define by the if temperature and pressure. For example, if any system is there and we can define the two independent intensive, for example pressure and volume, then rest other like enthalpy and all entropy, all we can calculate by using the thermodynamic relations. Clear है? अगर दो मिल गया सिंपल कंप्रेसर सिस्टम के लिए, अगर दो मिल गया तो रेस्ट जो है प्रॉपर्टीज उसको हम डिफाइन कर सकते हैं बाय यूजिंग थर्मोडायनामिक रिलेशंस. हाँ गर्ग साहब कुछ सब टाइप कर से बताइए क्या है. द नेक्स्ट इज थर्मोडायनामिक प्रोसेस. गर्ग जी बताइए. हाउ कैन डिफाइन द थर्मोडायनामिक प्रोसेस. प्रोसेस क्या होता है? द चेंज ऑफ स्टेट इज कॉल्ड एज, अगर स्टेट चेंज हो रहा है, इफ द स्टेट इज चेंजिंग, व्हाट इट मीन्स? इट मीन्स समथिंग इज गोइंग टू हैपन, some process is going to happen in the system, then only the state is changing. Yes or no? Mr. Aman, are you typing something? If yes, then please tell me. Process means what? When any state of system is changing from one state to other state. Change in state of system is called as thermodynamic process. Yeah. That change of state can be happen in two ways. One is called as quasi-static and non-quasi-static. Okay, I've told you change of state. So change of state in any thermodynamic process can be possible by two ways. One is called as quasi-static and other called non-quasi-static. Okay, the change in state of system is possible in two ways. One is called as quasi-static process, quasi-static, and again non-quasi-static. Quasi and non-quasi. What is quasi? Right on, first is quasi-static process. बोलो लिंक कर पा रहे हो नहीं कर पा रहे हो? मैं लाइन में लाइन चल रहा हूँ. Quasi-static process. Quasi means almost. Static means what? Stop or equilibrium. Static means stop. Stop means equilibrium condition. Which equilibrium? Thermodynamic equilibrium or equilibrium. Means not equilibrium, because once it becomes equilibrium then nothing is going to happen. That's why I have told you almost stop. It means it is not perfectly stopped. When it is perfectly stopped, completely stopped, means nothing is going to happen in the system. But it is going to happen through almost stop. It means the process is very very slow. Almost stop. So almost stop process is called as quasi-static. Clear? Not stop only, not perfectly stop. If perfectly stop, it means it is equilibrium condition. Nothing is going to happen. Here I am going to tell you almost stop. It means very close to stop, but not stop. Clear? So if the change of state is taking place through a very small, very slow, and very slow is only possible when the driving force, because what happen, for any process to be happen, there must be departure from equilibrium. Yes or no? अगर कोई process हो रहा है, if any process is going to happen, it means the equilibrium has been disturbed. There is a departure from equilibrium. The question is that how much it is depart. If driving force is very large, then the process is very fast. If driving force is very slow, very small, negligible driving force is there, it means very slow process it is. Yes or no? For any process to be happen, we must depart from equilibrium. We must disturb the equilibrium. Yes. It means almost stop process corresponds to infinitesimally small driving force. And for every process to be happen, there must be driving force. Yes or no? If any system is going to be changed in state, it means process is going to take place. And for any process to be happen, there must be driving force. If the heat transfer is taking place in system and surrounding, the driving force is, please tell me, if the state of the system is changing from one state to other state through heat transfer between system and surrounding. For example, a very simple. Let's say this is your piston cylinder assembly is here. This is the piston cylinder assembly. Simran, try to understand here. And this has temperature T1 and pressure is P1, volume is V1. Here it is allowed to interact with surrounding. Let's say T1 and head surrounding is T2 and T1 is more than T0. T0 is surrounding. T1 is more than T0. What happens? The temperature goes down. And if it is idle gas law is there, pressure remains constant because we have not put any weight. Then what happens? T1 is more than T0, then heat transfer is there. Then temperature will goes down, and after some time what happens? This will goes to T2, pressure is P1 as it is, pressure will not be changed, volume will be V2, and V2 is less than V1, am I right? Because T2 is less than T1, heat has been transferred. So this is the change of state because of heat transfer, na? So since it is transferring from system to surrounding, then driving force is temperature difference. So that system has changed its state from T1 P1 V1 to T2 P2 V2. Here P2 equal to P1. That is only because of heat transfer process. Yes or no? So change of state is there. Now I am going to provide you two examples. One example I am going to say. Let's say this is your piston here, and piston and cylinder. This is piston and that is cylinder. This piston has volume V1, temperature is T1 and pressure is P1. When it is allowed to interact with surrounding, anything, this is your system. I am going to, this system is there. This is your system. ये system है. Let's say this is system. Forgot about this. ये system है आपका अंदर वाला. ये system हो गया. Anything beyond system is surrounding. You know? So when system is going to transfer the heat to surrounding, system is transferring heat to surrounding. Now let's say T1 is given as 45 degrees Celsius, and to transfer the heat from system surrounding I am going to use the sink. यहाँ पे मेरे पास sink है बच्चे. The sink is there, and that sink we are going to attach with diathermic wall. Do you know diathermic wall? Anyone? Diathermic wall. And this is sink. Sink is surrounding actually. This is surrounding. This is sink, and that has temperature of 44.9999. Now there is a difference is there, but here the driving force delta T is close to 0. Yes or no? Not 0. When 0 is there, then nothing is going to happen. But here it is almost 0. Almost stop process is there. Then heat will transfer. But driving force is very small. It is almost slow process. Yes or no? And this heat will transfer until the system and surrounding will come to equilibrium with each other. Once its temperature become, volume will get decreases to a small amount. What is diathermic wall? The diathermic wall is actually the wall which are used to uniform temperature distribution. Now then temperature become here 44.999. Again we are going to use another sink having temperature of 44.8888. Again, now it means we are going to cool the process through driving force negligibly small. So that process is called quasi-static process, and ultimately we are going to continue this process to when temperature will drop to, when the temperature has to be dropped from 45 to 40 degrees Celsius, and for 40 degrees Celsius to be drop, let's say this temperature is become 40.111, and here it is 40 degrees Celsius is there. Then again heat transfer is there, and ultimately it become 40 degrees Celsius. Yes or no? So it will take infinite time, but what the benefit it is? Anyone? Benefit is कि every state. Now here what happened? It is initial state, one state, then second state. At every state we can define, every system we can define through state. system is going to passing through number of states, and every state, I've told you, a system is said to be a state when we can define the properties, and every state is in thermodynamic equilibrium. It means 1 to final, from initial to final, we are going to passes through number of equilibrium states. Yes or no? Through number of equilibrium state. Why equilibrium state? Because when we reach the 2 points, now at that time we can define the temperature is 44.999, pressure is this, volume is this. We have a well defined properties, uniform properties are there. Properties are uniform and invariant. Yes or no? At each states, properties are uniform and invariant. Yes, every state, I told you, key state definition is that key at that instant the properties system can be defined through state variables. So we are going to change the state from the, it means we are going to change the temperature from 45 to 40 degrees Celsius through infinite number of states, and every state is in thermodynamic equilibrium. Every state is in thermodynamic equilibrium. Means at every state properties are uniform and invariant. So this is called a quasi-static process. This is called as, please tell me, this is called as quasi-static process. Am I right? Bolo. This is called quasi. It means almost stop process is there. And the benefit of this quasi-static is that it is going to happen through almost stop, means with negligible driving force. From initial to final, there is an infinite number of thermodynamic states are there. One more example of quasi-static. Listen here. Let's say you have a piston cylinder assembly. I'm going to define another way. Pressure difference. Now that was in terms of driving force was pressure difference. Now I'm going to show you in terms of pressure difference. Here let's say this is your piston. Piston is there and cylinder is there. Here some gases are there, and here some grains are there. Small grains, very small grains are there. Now at that instant, I have to tell you, listen carefully. This system has some state. No, थर्मोडायनेमिक प्रॉपर्टी हम डिफाइन नहीं करेंगे. थर्मोडायनेमिक प्रॉपर्टीज डिफाइन होगा उस कंडीशन पे, क्योंकि वेल ऑर्गेनाइज्ड है सर. इस पे आप मेजर कर सकते हो कि क्या वॉल्यूम है, क्या टेम्परेचर है. प्रॉपर्टीज आर यूनिफॉर्म. ये वाले साहब, थ्रू ईच स्टेट वी कैन डिफाइन द सिस्टम. वी नो द प्रोसेस पाथ एक्चुअल. इट मीन्स from initial to final we are going to process through infinite number of states, and there is a well we can define the process path. What is actual path? Because initial and final is there, but through this infinite number of states are there. So at each state we can define, yes, it is pressure is volume, 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 it is pressure is volume. Are you getting this? Means we can define the properties at each states, in each intermediate states. That is meaning. Listen, that is more clear by this. Let's say at this instant, whatever the weight we have put it, although system and surrounding are at the same temperature. What I'm saying, कि temperature T1, pressure is P1 and volume is V1. And here also temperature surrounding is T0 and here T0 equal to T1. It means there is no driving force for the heat transfer. है ना? यहाँ heat transfer नहीं होने वाला है. And pressure, whatever the weight, pressure, because this system is in state of equilibrium. What it means? It means if this system is said to be in state, it means every state is in thermodynamic equilibrium. It means that is thermally, mechanically and chemically equilibrium. Yes or no? Chemical equilibrium is there because no any chemical reaction is taking place. Chemical equilibrium. Now why it is thermal equilibrium? Because temperature is same here. Thermal equilibrium. Now why it is mechanical equilibrium? Because P1, pressure exerted by the gaseous molecules on the piston, is equal to pressure exerted by the weight. If you know total mass of the weight, if m is total mass of weight of grains on piston, and mp is the mass of piston, then total pressure exerted by the grains and the piston on the gas is what? Total pressure exerted, called as external pressure. Total pressure exerted by surrounding on system. System is my this is my system. Piston is not in system. This gaseous are in system. Na? On system is what? You know the pressure is force upon area. Weight. It means m plus mp into z upon cross sectional area of the piston. Clear? This is the pressure force, and it is called as P external. If the P external, and this is called as P driving force, PDF, internal pressure called P driving force. If P driving force, it means pressure exerted by the molecules on the wall of the piston is equal to P external. What happened? They are in mechanical equilibrium, yes or no? Bolo, Simran. If the pressure which are going to be exerted by the gaseous molecules on the wall of the container is called as PDF, and since it is intensive, it is same in all direction. So if pressure P driving force is equal to P external, that is same. Then it is also in mechanical equilibrium, yes or no? So it is thermal, mechanical as well as chemical equilibrium, yes or no? And if you want to have a process, what you should do? You should disturb the equilibrium. You should have driving force. So if you are going to remove one weight, listen carefully. If you are going to remove this weight, what happened? Try to understand. Although you might not draw the figure, but you should understand. Okay. And here I have disturbed system by removing one weight. If I am removing small grains, then since every grain have very small weight, then there is small reduction in the pressure. A small reduction in the pressure is there, and I am going to show on the same axis so that you can compare. If the pressure will get decreases and inside pressure is more, then what happen? It will push the piston upward. The slightly upward is there. The piston will move slightly upward. The piston now will move slightly upward. Now it will move here. Initially that was there. Now initially move here. With nearly same grains, okay, slightly increase is there. That increase is very, very small, yes or no? Because driving force P external, here driving force is what? Driving force minus P external is very, very small. Bro, clear hai? Here one question you should ask, sir, why not you have considered the atmospheric pressure? Because this is the gauge pressure I am going to consider. Whenever I am going to gauge, then the atmospheric pressure should be taken as 0. Now, so very small increase in the volume is there. Pressure will get now, and now the new pressure will form here. As a new pressure, this is equal to what? Please tell me. This new pressure is obviously lower than the initial pressure. But again, this pressure will become equivalent with the new external pressure. Yes or no? Again, this new pressure will become equal to external pressure. Again, PDF is become again P external. That is obviously lower than the previous one. Again, they are in equilibrium condition, and that system is perfectly insulated. Otherwise, temperature will also get dropped. Listen carefully. Do you know this system is perfectly insulated, so that no heat transfer should be taking place? Are you mind? Otherwise, whenever any gas will be expand, then temperature will also always get decreased. Do you know? Expansion will always allow the cooling effect. Do you know? When the gas will expand, then always cooling will be there. Temperature will drop. It is very common sense, because initially the gas has been confined to a smaller space, then they are close apart to each other. But when the gas is allowed to expand in more space, then they are far apart, and that's why they will feel relaxed and temperature will goes down. That's why if you don't want to have an effect of temperature, then you should make it proper insulation. It is a thermal process. No? Proper insulation must be there. We have insulated this process. The only what change is there? Now pressure will decrease, volume will increase. No effect on temperature. Clear? Again, if you are going to carry the same process, where up to last grains are going to remove here, no grains are at all, then this piston has been moved to its maximum extent here. From, if you compare, but in between there is infinite number of states are there. What I am saying, infinite number of states are there. Infinite number of states are in between to reach from initial to final. It has passes through infinite number of states. Infinite number of intermediate states are there. Are you getting my point? What I'm saying? Bro, it has been passes through infinite number of intermediate states are there. Infinite number of intermediate states. And at each states, the process is in thermodynamic equilibrium. Yes or no? At each, let's say here 1, 2, 3, 4, and infinite number of states are there. But finally it reach here. This is the one method to expand gas from initial to final. Clear? When we remove all the weights. And at the same time, there is one more process is there, where the same condition I'm going to consider here. Same again, it is proper insulation is there, that is understood. Again, the same process is there. Now, all grains I remove a single time. All grains we have removed in a single time. What happened? It again reached to the final state as it is. It slams to the topmost position. It slams to the topmost position from initial to final. But my question is that, is there any intermediate states in initial and final? and that is called as fast process, because here driving force is fast, driving force in the pressure difference is very large, and that is called as non-quasi-static process. It is non-quasi-static. It is quasi-static. Now what happened in this case, now it's very common sense. When we are going to try to understand, there is a non-uniformity is there. Why non-uniformity? Why non-uniformity is there? Because once you have removed all the pressure at once, when you remove all the weight at once, any gaseous molecules which are near the piston, they affect immediate. They will feel just relaxed, because it is just common sense. If we are going to open the piston in vacuum, or you can say if you are going to simply remove all weight at once, what happened? The gas which are close to piston, their temperature is much lower than the, or you can say here the properties are not uniform. Pressure, they will lack low pressure. What I'm saying, if we are going to listen, if we are going to remove the weight immediately at once, lower pressure is going to be experienced by only the molecules which are close. But at this point, at the bottom of the piston, at the bottom cylinder, any molecules which are bottom to the, not temperature the constant, because insulation is there, Mr. Verma, but pressure decrease in the pressure is going to be sensed immediately by the molecules which are on the top surface close to the piston. But the molecules which are bottom of the piston or bottom of cylinder, they are not able to experience what happened. It is just like when in a classroom a class teacher immediately enters, then जो आगे वाले बच्चे होते हैं, they are attentive, but पीछे वाले बच्चे backbenchers, they just start their busy, you know, because they don't know the teacher has been entered in the class and the class has been started. Yes or no? The same thing is going to happen with the molecules. The backbenchers are not able to know what happened, because everything has been happened at once. So there is a non-uniformity is there. If non means here the pressure is different. Here the pressure at the bottom, and pressure at the top. Although I am not able to draw the figure, but I am knowing that you are able to know what I am saying. The pressure at the top is lower than the pressure at the bottom. So there is non-uniformity is there, and that cannot be defined as a state. In that case, it will take sufficient time to reach the uniform temperature. In meanwhile, what happened? There is a imbalance in the pressure is there. It means there is non-uniformity in the process variables are there. There is non-uniformity in variables, and they will take sufficient time to reach the equalize the pressure throughout. But what happened in that case? How can define the process? Let's say here V here. Initially, I told you this is the pressure. This is the pressure here. Yeah, because volume is more, pressure decreases. Yeah, here. This is the initial state I. When we decrease the pressure immediately, we reach this point. Finally, it is F point, P final, V final. But what about intermediate state? Do you know intermediate state? No. Do you know? You don't know what happened in between initial and final. You don't know. There's no proper states are there. You are not able to define the intermediate state here. That's why that is called as irreversible process, non-quasi-static or very fast process, and they are non-quasi-static process. Clear? And that's why they should be defined through dot line. And actually that is called as non-quasi. We are going to use dotted line because we don't know actual path. It may be like that, it may be like that, it may be like that. We don't know the actual path. That's why the better is that we should define through initial and final through dotted line. There is a non-quasi process, non-quasi-static, and there are also said as an irreversible process that I will discuss later on. I have not told you any word about reversible and irreversible. I have told you only quasi and non-quasi. So this is non-quasi-static. Clear? Now in quasi-static process, what happens? You have a well-defined path P and V here. They are specific volume. Be careful. Here initial and here final. But at every point there is a well-defined states are there, and we have a full line. This is called a quasi-static process. Quasi-static process. Clear? The quasi-static means almost stop when driving force is very small. So if you want to carry out the process in quasi-static manner, what the condition must be? You should carry out with very small driving force. Driving force will be very small. Am I right? Bolo. This is non-quasi. Means very fast process. Now the question is that what is the need of such a slow process? Why we are going to bother about such a slow process? Because in real practice, every process is very fast. If you are going to carry out in such a slow process, then every industry will get closed and every industrialist will come on the road. Yes or no, Mr. Karthik? because in real practice no process is going to happen. Have you seen any piston cylinder assembly, for example, in the vehicle, in the 4 piston cylinder engine is there, 3 piston cylinder engine is there, 3 cylinder, 4 cylinder. Have you seen? So here compression expansion are there. They are not such slow, they are very fast, and even we don't know the such a slow process. Now what is the role of this such slow process? Why we are going to bother about? Why we are going to waste our time in drawing this picture for such slow process? We should go for very fast, because real is very fast. I will discuss it later on, and I will also discuss what are the reversible and irreversible process. I have told you the quasi and non-quasi. The quasi process is almost slow process. It is clear? बोलो या तो यहाँ तक किसी को दिक्कत थर्मोडायनामिक्स में अभी तक समझ में आया नहीं आया? बताओ. सारे नॉमेनक्लेचर, सारे फंडामेंटल क्लियर हैं? कोई दिक्कत तो नहीं है सिमरन? जिसको टफ लग रहा था जल्दी हाथ उठा लो. तो आफ्टर द ब्रेक आई विल डिस्कस की व्हाई वी आर गोइंग टू बॉदर अबाउट सच स्लो प्रोसेस. सेकंड आई विल डिस्कस रिवर्सिबल एंड इरिवर्सिबल प्रोसेस. हाँ बताओ, टफ है? कुछ भी अभी तक तो मैं बताया नहीं हूँ पढ़ने वाला, जो आपको पढ़ना पड़े. ओके, तो मिलते हैं ब्रेक के बाद सेकंड लेक्चर में. आज बहुत कुछ खत्म हो जाएगा, डोंट वरी. मिलते हैं. कितने बजे क्लास है? 6 बजे ना? 6 बजे, 6 से 9.